Okay. So I wanted to decide, well, I thought about yesterday about renaming this talk to AEM Headless. Actually, it should be Jörg Headless. Because I often get the question, Jörg, we see you without your head. And now I want to give the answer right now to everyone, so I don't have to answer this, at least today anymore. In buildings, I don't wear a hat. That means when we are outside, you might see me with a hat. Inside, probably not. That means I will take off this hat right now, and I deliver this talk without a hat. And now, let's getting a little bit serious. Backend performance, well, having all these headless and Franklin stuff, well, they all assume, yes, performance is not a problem. Rendering is instantaneous. Well, it's not a problem. It's not instantaneous. We deliver everything out of the cache. We have CDN, we have Edge, all the cool stuff, and still, well, it's still a problem. I'm an SRE. That means I take care of the backend stuff. All the shiny front-end stuff, it's not necessarily my area of expertise, not the stuff I'm dealing with every day. Nevertheless, you build shiny websites, and you care about the last milliseconds on the browser. I often care about seconds. You think your CDN is always primed. I saw enough cases where an empty CDN is almost empty, everything hits origin. Raw backend performance matters at that point. We have customers who say, well, yeah, we need to do integration on the server side, we need to personalize stuff on the server side for whatever reason. It's still there, it's a requirement. It seems to be a requirement, I don't really know. I have to say, yes, I hope you made the right decision, but in that case, backend performance matters. And in case you are using old-style AEM, touch UI, rendering performance matters because the authoring UI, the page is not rendered not taken from the CDN, it's always rendered on demand. In all these cases, 6 seconds is really, really slow. And I've seen too many cases like where rendering a page takes 6 seconds, and then I'm mostly running out of options with auto-scaling because I can give you almost unlimited pods, unlimited CPU. We will always have problems. The only way we can solve this is getting away from these 6 seconds, coming down to at least 2, I would be happy. 1 is even better. 500 milliseconds, I love you. But backend performance is still a problem, even with all that shiny stuff. So, trick question to you. You know weekend? And when I render this, how many Sling resource objects are created? I have the option of 50, 500, 5,000, and 50,000. Who opts for 50? Oh, well, that was 1. Oh, you voted for 50. Okay. 500? Okay. 5,000? Okay, and who is always assuming the worst? 50K? Oh, still a few. Well, obviously it's not 50. That would have been too easy. 500, it's not 500. It's not even 5,000. But it's also not 50,000. It's 11,000 times. A JCR node resource object is created. That means we still have 4,000 times when the system tries to instantiate one, but there is none there. We have 5,000 or 6,000 value map creations just to render this silly page. The interesting thing is, all in less than 1,000 seconds. On my M1 Mac, 550 milliseconds. Still not a really nice number, 500 milliseconds to render such a simple page. Does it have to be 500 milliseconds? Nah. Anyway, what I want you to learn about this thing here, I want you to understand that the best proxy for backend backend's performance is the number of repository accesses you do in rendering. That means you access a lot of resources, your page will inevitably slow. The next thing I want you to learn to understand is that most of this repository access is actually not needed at all. You have a ton of redundancy at every level. And that the solution of this is getting rid of that. And in this talk, I want to show you how you can do it. How you can identify the performance bottlenecks in your website or in your system, in your rendering process, well, by finding out, okay, which resources do I access at which place? And then you can think about it, is this necessary? How can I get rid of it? Is there a clever way to avoid it? Okay, so let's first, what is repository access? Well, the usual suspects here, resource resolver, get resolve, resource list children, get resource, get properties, the same on a JCR level. That means it doesn't matter if you use a resource or JCR level. Here I counted only the resource level. I think there might be some direct JCR accesses by the weekend application. If they are, I haven't accounted for them. But, well, the thing is, when you have a lot of JCR direct access JCR directly bypassing Sling, it's the same. And next thing is, we have what happens during this repository access. Why is it a problem at all? Why can I use this as a proxy? That means, why is it slow? Well, on the JCR level happens a lot. I'm not a really JCR expert in the way that I understand the code, but I learned a little bit. Validations, access controls, a lot of other objects are instantiated, and additional data might be read, let's say reading from a namespace, a registry, or reading children lists. That means if I want to, well, has this resource a child name called JCR content? Well, first of all, it needs to read all the children, iterate through the list, and then, okay, I found it at position 3. Great, but at that point, I already had read the children list of 50,000 children of that node. Can be. There is a little bit of Sling overhead, but that shouldn't matter here. Use Sling. JCR has no benefit in terms of performance. And the one thing you should remember as well, I/O is not a problem. Normally not the problem. There are cases where it can get the problem, especially Cloud Service Author with Mongo. It can get a problem. But in normal cases of publish rendering, storage is local, we have plenty of memory, memory mapping. Actually, the stuff lives in RAM, and the problem is getting through all the stacks to actually get access to that. So a few rules of thumb. So whenever you do thread dumps and you see code is operating somewhere in Oak, it's very easy to blame Oak. But as we learned, it's not the individual access which is slow, but the problem are the 11,000s. Nevertheless, a few rules of thumb. When I creating a node, that means access a Sling resource, 15 to 20 nanoseconds. That means I can read quite a lot within a millisecond, and I can read even more in 1 second. That means in 1 second would be 50,000 nodes I can create. Now you can imagine when a page takes 6 seconds to render, how much resources it actually reads. Roughly, well, 300,000 if I've done my math correctly. And of course, it gets slower when you have the biggest thing is typically ACL, the thing you can, well, have the biggest impact on. It's when you put a ton of ACL, and that then needs to evaluate a lot of ACLs. Another rule of thumb, resource resolvers are costly, taking 1 millisecond. I have had a case where in an abstract sling model in the, well, constructor, they opened always the resource resolver. They could use it. They might be useful to have one around. Well, now you have 150 of these sling models on a page. That means just 150 milliseconds spent on opening a resource resolver, which we don't need. Yeah, we might need it once, probably, normally not at all. Means there is a lot of, different ways to actually waste your time or to waste rendering time. So, and the problem is really that we are accessing the repository way too often. A single access to the repo is not a problem. It's the pure mass of it. I've listed here for this weekend page I just showed you the most frequent accessed resources. And it's a little bit fun, right? It's not the thing you would expect, which is on top of that. We're reading 1,000 times something on the editable template stuff. And then conf, we read 260 times the root node. What for? And I think at position 8 now we have the first time it's the actual page we want to render. And that's an interesting thing, interesting learning, and well, probably already hints where the problem actually is. Come to that later on. So the thing is, when we know repository access at scale is a problem, it makes stuff slow, how can we avoid that? How can we avoid repository access? That means, of course, a few very general recommendations. Avoid them, yeah. I think I see a lot of code where it's actually, well, I have a resource, get path, and do some string operations on the path, and then I resolve this again to a new resource. And this is a common pattern I see across the place. Sometimes it's necessary, many cases, yes. Something like resource get parent does the same what you do on a string operation. I don't know, and that's of course a little bit cheaper than resolving a resource again. But many cases, the universal way to provide references to something in your code is string the path. The path is passed around instead of the resource. And then every method resolves the resource again, and again, and again, and 3 and 4 and 10 times. It's a very common pattern. That's a very easy win. And of course, yes, saving 5 times the repository access, well, it's 100 nanoseconds maybe, you don't feel that. Well, but at scale, and if that's in an inner loop, that it means it's actually executed 100 times during page rendering, it can get significant. That means resource to string to resource, bad pattern. And of course, well, that means operating on resources and resource resolvers and avoiding JCR completely. That's the best thing you can do whenever you can. And honestly, I'm trying to fix the few JCR-only APIs in AEM. It's probably not that easy to do, but in many cases, well, operate on a JCR, on a Sling level, don't adapt to a session, and operate then on the JCR session. But I think this has been a recommendation forever, I think. Redundant resource resolvers, a common thing. I'm not talking about closing resource resolvers, because probably you have heard this forever from me. But opening, 1 milliseconds. 1 millisecond is still can be significant, especially if is it done a few times. For example, this weekend page is opening, or is using 4 resource resolvers to display the page. Well, 2 of them are necessary for the scripting and that stuff, but for internally it uses 2 to render. And I came across many codes and many applications where page rendering requires 5 or 10 or 20. All not necessary. And technically, during a request processing, you shouldn't be required to open any new resources over. Because if you have access, if you're on a publish side, and if you access stuff, well, you see, yes, this area there, it's not available to anonymous, but every request needs to read it. So what's the difference? Why do you want to protect it, and if every anonymous user accesses it anyway? You need to open new resources over. Yeah. A little bit of overhead, maintaining ACLs, and maybe some stuff will be even more complicated when you always need to open a new resources over. So it's yeah. It's a thing where I gave frequently recommendations out to customers saying, okay, make this code easier, because this will save you a few milliseconds, and not the few milliseconds is technically not the big win, but, well, when we save 100 times a few milliseconds, then it will be significant. Abstractions. Abstractions are a cool thing, right? Abstractions save you a lot of time and a lot of work. And we have a few abstractions which are very super useful. For example, the whole script resolution. It takes care of overlays, all that stuff. Context-aware configuration is great. As a user, I loved it. Because it will, I configure it in some magic way, only Stefan can explain. And yeah. And then it resolves me the information, no matter if I have placed it in conf or in disconf or on the page or whatever. From a performance point of view, this is chaos. This is horrible. Because, yes, it looks at all these places and checks if something is there. And even if it's not resolving a resource, it still looks up there, and that means it needs to go to the repo, and okay, nothing here. Proceed, check the next place, check the next place, and there, it goes on and on and on. Script resolution is something similar. Well, if there is nothing here, means if you want to resolve the lips CQ page resource type, first check synapse if it has been overlaid. Always a repository access. Well, can you get rid of it? Probably not. From a framework perspective, we need to offer this. But I hope you don't always develop frameworks. I mean, in your case, you should know where stuff is. Sling models, it's a cool abstraction anyway, as well. It can create a lot of overhead. AEM itself, well, let's not talk about AEM. It's yeah. So let's come to Sling models. That's great, a cool thing actually, cool technology, and I actually liked that the first when they said, well, inject will basically magically inject from all injectors which are in the system. That means you can inject properties, you can inject child nodes, you can inject objects, you can inject whatever. I think there are 6 or 7 default injectors around. And the combination of optional is even better, because it's a great way to cause null pointer exceptions. Well, optional, yes, it can be there. The property can be there, it cannot be there, I don't care. Yeah, if you're not playing defensive, well, null pointer exception are the result. But on the more, from a performance point of view is, well, optional says, well, it tries to inject, go through all injectors, and optional says, well, if it fails, it doesn't matter. Next injection, also annotated optional. Same again. I had a case where customer was, I think they, in some special request, they tried to instantiate 1,500 Sling models. And I think every one of these had 3 optional injects there. They were all not, some are resolving, some are not. But they were complaining, well, it takes 4.5 seconds to execute this request. We expect it to be faster than 2 seconds. Because in AMS it was running on 2 seconds, in cloud service it was slower. Okay, look in there. Well, yeah. All your optional injects, you actually try to inject a value, a property. But because the property was not there, the system tried to inject a child node. Oh, repository access. It went through, tried to inject an OSGI value. Well, probably that was a little bit faster to actually say NAP, no value for that, no OSGI service. But that was a very easy thing. That means they were causing in all these 3 injections, these 3 failed injection was causing an overhead of 200 milliseconds or so. Times 1,500. That's a significant number then. And we were all, I think I said, replace all of these injects by value map value, and that's it. And well, they did it, 2 seconds, immediate win. That means inject, well, is bad. Is bad. I changed the sling. I changed the sling side saying don't use inject anymore, use the specialized annotations. Because of that, because of performance. And optional, yeah, as mentioned, I've seen too many null pointer exceptions in code. It's too easy. The next thing is, Sling models are great. I optimize them. For my case, I use value map value where I need a value map value. But I have 100 injections. Yes, that's my Sling model I use here. That means in the end I create a complex and expensive Sling model, and then I call a method just once, which effectively just needs one of these values. But I inject all the 100 to use one. Well, it's a little bit overhead. I mean, wouldn't be a smaller tailored Sling model do the same, which just provides this value? In this example here, I have a generic product class which does 20 injections, and then I just ask it, is it a shirt? One value, and then it's not used anymore. That means it's pure overhead. I could use something more like it's a shirt product, which is much easier to create, less expensive, maybe just one injection, specifically tailored for this. You can do that. It's not a problem here. It's just that you need to be aware what you use your Sling models for. If you use it just for these if you need them always, all properties, or a lot of them, then it probably doesn't matter. But if you're heavily using and just, okay, I instantiate the Sling model and then I read one property and then I throw the Sling model away, yeah, probably you can do better, improve performance when you create a dedicated and smaller and tailored Sling model. And then let's talk about the elephant in the room, AEM. It's nothing new, the first statement, that not all parts have been optimized. I think if you compare the raw performance of the old geometrics against Weekend, we know what the winner is. I started to work on that. It takes a little bit of time. Isn't that easy? I have later some POC data to share but the most obvious improvements work for 98% of our customers, but they need to work for 100% of our customers, and that it always makes it a little bit harder to actually roll out these improvements. Anyway, okay, so I told you, well, what you can do, but still, yes, where does my performance go? How do I know where I should start? So I added a few months, maybe even a year back, 2 additional log facilities on a Sling level. You can enable them on trace. Don't do this in production. The first one, when I run a single weekend page, it creates a gigabyte of log. A colleague of mine actually tried to run a GraphQL query, 340 gigabytes of stack traces. Second one is just, X just shows the raw number. Here is what you see. This is how a stack trace looks like. The interesting part is, of course, at the top. Nope, don't ask again. It says here, invoked new JCR resource on this path. And so goes on and on and on, and you have always the whole context. And you have, of course, you find a ton of Sling, you find a ton of AEM code, but if you run your own stuff, well, yeah, probably we probably need to search for weekend code. But if you have your own class and your own code shows up at some point, you can easily search for these and identify the stack traces and find out what your code is actually accessing. And, well, I did something for the Sling resource resolver.map code. I try to identify which paths are resolved by, or mapped through the resource resolver map API. And actually, this is what we will get. And now you see maybe a pattern, and you can ask yourself, why does this thing always access content, content weekend, content language masters, la 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 la? Is there any value in that? Is there a way to optimize it? That's the question we should ask. Actually, I'm on that already, so you don't have to tune that anymore, but you can check your own code with that, trying to find out what it's doing, especially if you have a 6-second page. This is definitely, well, it probably will have a lot of free disk space, but this will tell you a lot what your application is actually doing. Okay, how to improve? Well, of course, inner loops are always best when you know where the inner loops are, and looking at them, optimizing them. Remove redundancy and cache the results. We have a relatively new, and I like that, we have a cache on a resource resolver level, which lives with a resource resolver. That means you can store resources in there. They will be disposed when the resource resolver is closed. Actually, write a thing. That means, and if you don't share the resource resolver, and I don't know why this. Don't try to do that. Honestly. Okay, let's just go on with that. I've just 30 seconds left. So anyway, what can you expect? Some things I did a POC, touched a lot of points in the product, and were able to improve rendering of the weekend page by 40% without touching any weekend code. It's just removing overhead from the framework. A lot of stuff from AEM. That means there is still a lot of overhead in there, and I want to eliminate it. That means at some point you can hope that AEM will contribute its part to speeding up your application. Of course, there are a ton of minor things, let's say script resolution process. Yeah, I have to fight for that because this is a very core part of Sling. But I think we can get 10 to 15% for site admin because it does a lot of internal Sling resolution the way it is built. You get less for pages. I'm working on map, on Sling resources over map, and then they have a few areas. But of course, your code does as well, because I cannot imagine that AEM is responsible for 5 of these 6 seconds these pages take. I don't think so. Okay, conclusion. You all heard, well, front-end stuff matters. Yes, it matters. But think about cold caches. Cold caches is a problem. And sometimes we have cold caches more often than you actually think. And avoiding the repository access is a very efficient way to improve performance. That means I use it as a proxy. That means counting with these log facilities, you can now start counting, and you don't need to do a performance test. You say, well, 10,000 times a repository access is definitely faster than 11,000 times. Around 10% maybe, 8 to 10%. Good enough, and definitely worth to do that. And the big thing is here, the approach you can apply on all AEM versions. 6.4, 6.5, cloud service. These loggers are just there in cloud service, I think. No, not sure if the backports have been already hit 6.5. But, well, you can try to apply it manually. Or then just install an SDK and work on them on that point. Okay, thank you. I hope I can help you and that I don't see these 6-second pages anymore for a very long time. Thank you.
So, Jörg Henry would like to know, when adapting a resource to a value map, and that happens very often for the same resource, a value map backed by a fresh JCR property cache is created every time, which makes the cache not very useful. Is there any plans to improve that?
Well, I think when you adapted it once, it might be even stored there. The problem is when you're adapting it from, let's say, one of these 1,000 instantiations of these editable template stuff, for every resource, you need to do it once. If you have done it already, it's cached at that point on a resource level. But if you adapt the same path, or if you resolve the same path to a new resource and try to adapt again, then of course it will be read again. That means the value map cache is not shared across all resources for the same path.
Michael is curious, what was the setup used during you took the measurements? What was the repository size, and how would the usage of document node store change the results and timing?
Result was my MacBook. I did the tests on an SDK with Weekend in state of probably May or June. Document node store would not affect the numbers, but of course it would affect the timing. But let's say less repository access, faster page is even in document node store. That means you will have always a benefit from it. No matter, even if the document node store puts an additional penalty on latency on top.
Bart suggests, should Sling models just support a lazy injection then?
Radu? Lazy injection for Sling models? Konrad? Okay, Konrad is not really, is Konrad is lazy as well. That means, yeah, technically it could work, but at one point you have to think about the overhead of this laziness if it really is worth. But interesting idea, already thought about it, but I think I have the things I'm trying to fix are much easier to do than writing more annotations.
Excellent. There are quite some more questions. I'm sure you take
Yeah,
care of.
I will take care of them.
Exactly. And now, next stop, lunchtime. And we see it all at 1 o'clock back here in the room.
And no hat here.